In this video, we'll be covering Chapter 11, Section 6. It's events involving nor, and, or. We'll also be talking about how to calculate odds. The first part here is the probability of an event not occurring is notated as the probability of E naught. If you remember from the previous unit, this little notation, the complement, means it is the opposite of. The probability of not E is going to be equal to 1 minus the probability that E occurs. Let's look at this example here. It says, if you are dealt one card from a standard 52 deck, find the probability that you are not dealt a diamond. So here's my list. Diamonds are right here, which are 13 cards. So if I'm going to be figuring out the probability you're not dealt a diamond, let's find out the probability of being dealt a diamond. So there's 13 diamonds out of a total of 52, which means that 1 out of 4 of the cards are diamonds. So the probability of not getting a diamond is going to be 1 minus the probability of getting a diamond. So 1 minus 1/4. The probability of you not getting a diamond is going to be 3 out of 4. Which makes sense because there's 3 other suits to choose from. So clubs, spades, or hearts, and the only one you don't want is diamonds. The next example says, find the probability that a minute of the NFL broadcast is not devoted to commercials. In the figure here, it shows the breakdown time for an average 190-minute NFL TV broadcast. So if we're not devoted to commercials, what I can do is find out the total number of minutes. Well, it's 190 minutes. It says so right here. So then I want to find the probability of having a commercial. Well, remember the probability is going to be a fraction, which is part of something occurring out of the total. So 63 minutes divided by 190, that's going to be the commercial part. So if I wanted to find the probability of not it being a commercial, I'm going to do basically 1 minus, well, if it's commercial. So the probability of not having a commercial is going to be 1 minus the probability of having a commercial, which is 63 divided by 190. And then I entered this into the calculator, found this to be 127 divided by the total of 190. So this is going to be the probability of there not being a commercial. The next example says, if one driver is randomly selected from the population represented, find the probability expressed as a simplified fraction that the person is at least 20 years old. So in this table here, we're given the number of cars driven by their age groups. So this is the first number here is the age group, and then how many people are within this particular age group that is driving a car in the United States. So first thing we want to do is find the total. It does not give us the total in this table, so we just added up all the different age groups, and we found there to be 214 million. It says find the probability that the person is at least 20 years old. So I'm going to say at least 20 years old. Now, when I'm looking at this table, you will be able to see that 20 years old is here, and then it keeps going up. So instead of adding all of these up individually, what I can say is the probability of being at least 20 is going to be 1 minus the probability of not being 20. Here, there's only one category that is not 20. So instead of adding everything up individually, I can just say 1 minus this category. So the probability that you're not 20, well, there's 9 million out of 214 million. So the probability of being at least 20 is going to be 1 minus the probability of not being 20. Go ahead and put this into your calculator, and you get this simplified fraction of 205 divided by 214. Mutually exclusive is going to be the next topic we're discussing. Okay, so mutually exclusive means that it is impossible for two events to occur at the same time. One of the examples I like to use is if you're in a mutually exclusive relationship, it means that you either have a boyfriend or you have a husband, but you do not have both, okay? Other examples would be if I roll the dice again, it's either going to be an odd number or it's going to be an even number. There's no way for both of these to occur at the exact same time. This equation can be found here on your formula sheet. Notice that it says here when A and B are mutually exclusive. When they're not mutually exclusive, we'll be using this other formula here. Let's look at an example. If you roll a single six-sided die, what is the probability of getting either a 4 or a 5? So the first thing you want to notice here is that word or. It says a 4 or a 5. These events are mutually exclusive. We cannot get a 4 or a 5 at the exact same time. So when this is true, it is called a mutually exclusive event. That means what we're going to have to do is add up the probability of getting a 4 plus the probability of getting a 5 individually. Since the probability of getting a 4 is 1 out of 6, and the probability of getting a 5 is 1 out of 6, we would simply add those two numbers together, and we get 2 out of 6, or 1/3. Now let's talk about probabilities with events when they're not mutually exclusive. Okay? Again, your equation can be found here when it's not mutually exclusive. When it's not mutually exclusive, what you're saying is that two events can occur simultaneously. So for example, if I said, what is the probability that the card chosen is going to be red or a face card, you can indeed have a card that is both red and a face card. If I look at my list here I have my black cards, here are my red cards, and these are called my face cards. So these two things can occur simultaneously. When we have a situation like that, what we're going to do is add up the individual probabilities, the probability that the card is red, the probability that the card is a face card, and then we're going to subtract the probability of it being both. And the reason we do that, let's just say this, okay? So here, these are all the cards that are red. Then I'm going to look at the face card. When I say the word or, I'm saying, well, it doesn't have to be red. It could also be a face card. Look at what I've done here. I've actually circled the ones that are both red and face cards twice. So what we're doing is we're adding up the probability of being a red card, the probability of being a face card, and then I'm subtracting one of these circles that I've already included because we've added them twice, so we have to subtract it one time. And that's what we did here. This equation here can be found on your formula sheet right here. It doesn't have the note on it, so these are the ones that you use when it's not mutually exclusive. Example 5. In a group of 50 students, 23 take math, 11 take psychology, and 7 take both classes. Notice that some students are both in psychology and in math, so it's not mutually exclusive. If one student is selected at random, find the probability that the student is taking math or psychology. So what I'm going to do is find the probability of that student being in math, and I'm going to add that student being in psychology, and then I'm going to subtract the students who are in both, because remember we counted them twice. So 23 out of 50 are in math, 11 out of 50 are in psychology, and then minus 7 out of 50 are in both. So the probability that the student being selected is in math or psychology is going to be 27 out of 50. Make sure this is simplified and you can use your calculator for that part. Number 6. A spinner with equal parts are labeled 1 through 8. What is the probability that the pointer will stop on a number less than 5 or an odd number. Because there are some numbers less than 5 that are also odd, this is not mutually exclusive. The first thing I ended up doing here was going ahead and listing our sample space. The pointer can land on anything between 1 and 8. Okay? So the probability of it being odd, well, we're going to figure out how many numbers are odd. There's going to be 1, 3, 5, and 7. That's 4 out of 8 numbers that are odd. Or in other words, half of the numbers are odd. Then we're going to look at the numbers less than 5. Again, here we have 4 numbers less than 5. It doesn't say equal to 5, so we're only going to count 1 through 4. So 4 out of 8 numbers are less than 5, in other words, another 1/2. But when you notice here, you can see that some of the numbers are counted more than once. We use the 1, and we also use the 3 twice. So on this part, I use that word and. Remember, it has to have both of them. So 1 is in both categories, and so is 3. So here, I have 2 out of 8 that are exactly the same. Don't be confused. Don't put this out of 4 because we're still looking at the total sample space, which has 8 numbers. So 1/4 are both odd and less than 5. So the next thing I did here was go ahead and write it out. There's a probability of being odd is 1/2. The probability of being less than 5 is also 1/2. And the probability of being odd and less than 5 is going to be 1/4. Use your calculator. You get a probability of 3/4 of picking a number that is either odd or less than 5. Number 7. Refer back to the table 11.3, the marital status. If one person is randomly selected from the population, find the probability that A, the person is married or female. So let me pull out that form. So what I'm going to do is go ahead and circle the people who are married, and then I'm also going to circle the female row. The easiest way to look at this is if you have any kind of number that is double circled, this is considered not mutually exclusive. So here it's not going to be mutually exclusive because we circled it for being married and also for being a female. Probability of being married plus the probability of being a female minus the part that I've circled twice. Okay, so in the married column, we have 133 out of our total, which is 254. So I have that there. Plus the female portion, I have 131 out of 254 that are female, minus the part that I circled twice, which is 67 out of the total, which is 254. Use a calculator just for the numerator part, and you should get 197, and then the denominator will stay at 254. Part B says, what is the probability that the person selected is divorced or widowed? So in this particular case, I'm going to go ahead and circle the divorced people, and I'm also going to circle the widowed people. Notice in this case, there is no number that is overlapped twice. So because the circles are completely separate from each other, this is going to be considered mutually exclusive. So now we have a mutually exclusive event. They do not intersect. Since they are mutually exclusive, all we're doing is adding those two individual probabilities together. Here for the divorce column, we have 26 out of 254. That's stated here. And the widow column, we have 14 out of 254, which is here. Add these together, you get 40 out of 254, and then you can simplify using your calculator, and you should get 20 out of 127. So the last part of this section is going to be covering odds. There's two different types of equations for odds. When you say odds in favor of, what you're talking about is the probability of being in favor divided by those who are against it. If we say odds against, the probability of being against is in the numerator, and the probability of being in favor is in the denominator. I want you to note that the denominator in this particular case is not the total. Remember, when we're looking at probabilities, the denominator is always going to be the totals, but when we say odds, it's not the totals. It's going to be the people who are for it versus the people who are against, or the people who are against it versus the people who are for. If I add up these two numbers together, that would be the total amount of people who participated in this particular survey. Let's go ahead and look at an example. Number 8. You are dealt one card from 52 deck. Find the odds in favor of getting a red queen. How many red queens do we have? So here we have 2 red rows and we have 2 queens. So we have 2 red queens out of 52. So the probability of getting a red queen is only 2 out of 52. The probability of not getting a red queen, well, if we have 2 that are red queens, that means 50 are not red queens. So when we're looking at odds in favor of a queen, we want to put the 2 over 52 in the numerator and the 50 over the 52 in the denominator. Now the good thing about this part here is you'll see that the 52s will cancel, which is just left with 2 over 50. If I simplify that, you get 1 over 25. So the odds in favor of getting a red queen is denoted like this, 1 to 25. Find the odds against getting a red queen. All I'm doing here is putting the probability against getting a red queen first, saying that there's 25 to 1 card in favor of getting a red queen. Number 9. Number 9 says the winner of a raffle will receive a 2-year scholarship to college. If 1,000 tickets are sold and you bought 5 tickets, what are the odds against you winning the scholarship? The first thing we could do is either calculate the probability of winning or of not winning. So if you're not winning, there's 995 cards that you did not buy. If any of these cards are chosen, you're definitely not winning. So 995 divided by 1,000 that were sold are not going to be in your favor because you don't own them. Now the probability of you winning, you will have 5 chances out of 1,000 because you bought 5 tickets. So the probability against you winning is going to be 995 to 5. Simplify this and you can say there's a 199 to 1 chance that you will not win the scholarship. Now when we're talking about odds to probability, what we're saying is A is in favor, B is against. If you want to change that to a probability, remember that A and B must be added together to get your total. That's what I have written here. This is the total amount. The probability the event occurs is going to be called your A in this case. So let's look at this last example. The odds against a certain horse winning are 15 to 1. Find the horse winning and the odds in favor of the horse winning. So the odds in favor of the horse winning, all you're doing is flipping it. You're saying that horse will win and the other 15 horses will not win. So the probability of the horse winning, well, if there's 1 horse that wins and 15 horses that will not win, that means that there's 16 horses in the entire race. And how many will win? Well, only 1 horse will win out of 16. So the probability of the horse winning will be 1 out of 16. All right, that concludes the lesson over 11.6. Please let me know if you have any questions.